I'm Frank and this is my latest project, Data-Navigator, an accessibility-centered data navigation toolkit. This work was in collaboration with Lucas Nadalskis and Dominic Moritz. This is a bar chart. Let's say it's interactive. I might be able to hover, using a mouse to see a tooltip. Or perhaps I can even click the bars in order to do something like open some data, or filter, or go to a web page. But data visualizations often only have mouse support, and sometimes limited touch support. Support for screen readers or other assistive technologies and input modalities pretty much doesn't exist in most toolkits. Making data visualizations accessible for people with disabilities is, of course, important. But how do we get there? How can we realize this goal? Research on what users with disabilities want and need, and accessibility standards and guidelines aren't enough. The toolkits and ecosystems we use to craft data visualizations must give designers and developers the ability to follow best practices and explore new design ideas. But as it stands, toolkits have a ways to go. Access for many assistive technologies is a navigation problem, and most toolkits out there offer virtually nothing to developers to design and control navigation experiences. For example, screen readers, which are typically used by blind and low vision users, navigate content, and other devices may rely on keyboard, voice, or gesture inputs. These devices typically have discrete or direct navigation controls and may be used by people with motor or dexterity disabilities. Some of these devices have been around a long time. For example, shown here is a wheelchair user who's using a sip and puff device from the 1960s. This controls and navigates a computer using breathing patterns. These devices are actually still used today. And what about the future of input devices? Future and fabricated interfaces in particular are a subject of study in accessibility contexts such as physical therapy, rehabilitation, working with children with disabilities, and the elderly. One particular study that I love from 2014 used objects that could be found in a kitchen, primarily produce, to create a tangible interface in an aging community setting. Visualization toolkits currently cannot handle the assistive technologies of the past, let alone the future. So I'd like to present our project, Data-Navigator. It's a system that provides an entirely new accessibility substrate. Data-Navigator adds navigable structure, input handling, and rendering capabilities to data visualizations. We intend for our system to work in tandem with toolkits, allowing them to provide robust accessibility capabilities downstream to their users. I'll give a brief demo. This is a PNG chart from HiCharts. The chart isn't interactive. It's literally just pixels, but I use Data-Navigator to make it navigable and interactive. I'm first navigating this chart using a keyboard. The title, axes, legend, and all the bars in the bar chart are now accessible thanks to Data-Navigator. And Data-Navigator's renderer also adds semantics and text descriptions for screen readers. Using our input handling subsystem, I can navigate by swiping in various directions on a touch device, and even gesture with my hands using a simple gesture detection model. Voice commands and type to text also work, which are in our live demo but not shown here. And we also wanted to validate and test future interfaces, so we replicated a version of Roger et al.'s fabricated produce-based input system just to show the power of Data-Navigator. You're welcome to explore our live demo yourself as well. You can find the link in our paper. So Data-Navigator is actually built on a graph structure. A graph is formed out of nodes and edges. These are our primitive elements. And nodes and edges can, of course, be used to represent almost every other data structure. They can create lists, tables, hierarchies. But they can also be used to represent network graphs, infographic and mathematical diagrams, flows, spatial structures like maps, and even custom paths through a visualization story. Nodes can be virtually anything structurally. Individual data points, groups of data points, or even information like a title, access label, visual feature, or annotation. Our edges, which have navigation rules, can also be anything. Our rules are abstract. So left, right, up, down, or even a rule like legend can exist on an edge. Our rules are whatever makes sense for the visual. Lastly, rendering is an issue for toolkits. As an example of this, the charting library HiCharts has both SVG and raster-based rendering options. We used a raster option earlier in our demo. You can render the exact same data visualization using either method. However, rendering with SVG is actually usually more accessible by default, while rendering with raster is much faster. This means toolkit developers are in a bad place. They're offering a more efficient technology that excludes people with disabilities. That's not good. However, Data-Navigator's rendering subsystem creates an accessible HTML layer and provides full control to developers over the styling and semantics of it, so it can integrate seamlessly into a visual design. This HTML layer can be placed over any graphic, rendered in any way. Our whole subsystem lazy loads every element, which means that it's really fast too. In our paper, we added Data-Navigator to Vega Lite's canvas rendering programmatically. This allowed us to automatically add navigable accessibility to quite a lot of basic visualizations that Vega Lite renders. And the best part is that our system is lightweight, initializing in about 10 milliseconds for a chart with 20,000 data points. That's fast. Data Navigator can be used for exploring novel and unaddressed navigation designs. Our blind co-author and co-designer Lucas Nadolskis and I designed schemas for navigating vector and set diagrams and made prototypes using Data Navigator. Check out the paper for more. So what's next? Well, we believe that our technical contribution opens up several lines of co-design and human studies work. What do users whose disabilities have been unaddressed by current literature want and need from an accessible interactive visualization experience? We should work to establish ideal patterns for use, especially for visualization types that are not well studied. And our most immediate future work is towards practical aims. We intend to provide a user interface for building navigation structures. Users could create nodes, connect them with edges, and declare navigation rules. We hope this will help teams like data journalists who might build charts and graphs that need design finesse really control their accessible navigation experience without having to write any code. And we're looking for collaborations. Are you building a charting library or part of a team like a news organization that puts out charts and graphs? I'd love to talk. Please reach out. Thank you.